Good morning, everyone. Thanks, Tim, for the introduction. So my name is Kavon Nasabzadeh, and I am the CEO of Ofinno. And today I'm going to be talking about global technology trends and standards. And specifically, I'm going to be focusing on artificial intelligence, or AI. So this is going to be more of a technical discussion. With that. So at Ofinno, we have a research team of about 45 experts that are working across 3 different standards areas: 5G, Wi-Fi, and video compression. And one thing that I learned while working across all 3 of these different standards area is that there's not really one relationship trend between standards and AI. There's actually 2. And I think a lot of people may consider it to be a single trend, but I think it's actually informative to think of it as 2 separate trends, because you really start to see how pervasive AI is becoming in everything that we do today, and will become even more so as we move on in the future. So before just introducing those 2 relationship trends between standards and AI, I thought it'd be useful to go through what is AI at a high level, and that might lead you to these relationship trends yourself. So what is AI? So this is one particular definition that I thought was a good definition of AI. So AI is a machine's ability to perform cognitive functions like reasoning, learning, that we usually associate with human minds. And machine learning based on neural networks is probably the most common form of AI that can extract meaning from complex data to find patterns and detect trends that may be too convoluted for humans or other computer techniques. So just to provide a little bit more context, I'm not going to go into the weeds here, but to provide a little bit more context, I want you all to imagine you're back at college or in school, right? We're all back in a university right now. And I want you to imagine that you're trying to predict how well you're going to do on your test that you have the next day. And you're going to do that based on 2 different inputs: the amount of minutes you studied for that exam and the amount of hours you slept the night before. And so one way you can actually perform this prediction is using something called a neural network. And I'm showing a very simple example of a neural network here. So the way this would work is you would feed in the amount of minutes studied and hours slept into this neural network, and they would be passed to a set of neurons at an input layer. And those inputs would then be weighted and then passed to additional neurons in one or more hidden layers. And those hidden layers would accumulate those weighted values and then pass that subsequent value to another neuron at an output layer. And there would also be additional weights in between there. And at the end, you get a predicted test score. And to make this neural network model work properly, you have to do something called training. You have to train it. And you train it based on a data set of known values. And that's what I'm showing up in the top right-hand corner here, a data set of known values. So you would take one of those known values, like minutes studied of 12 and hours slept 9, feed it into this neural network, and then see what the predicted test score is. And you would compare it to the actual test score. And whatever that difference is between the predicted result and the actual result, you would then use to adjust the weights in this neural network, right, to better predict the test score. And if you do this properly using something like a gradient descent algorithm, and you do it over enough data points, you can actually get this neural network to do prediction pretty well, right? And in effect, what neural networks are really doing is they're approximating a function, right? In this case, it's a relationship between the inputs of minutes studied and hours slept and test score. And I provided a little plot of maybe how this function might look, right, in 3 dimensions. So you're really trying to approximate functions using neural networks. So this is just a very simple example where you have 2 input variables. But you can imagine a much more complex function where you have 100 input variables, right? A very high input dimension problem. And in that case, you really see the power of neural networks, that they can be used to approximate functions of that complexity. And so one thing that people in this room likely know, right, is that standards are becoming more and more complex with every single iteration and generation. Right? 5G is becoming extremely complex with the amount of use cases it's supporting and the diverse set of wireless devices and UEs. And so there's many complex problems that neural networks can be applied to in standards. And that's kind of what we're seeing. We're seeing the beginning of that trend where AI is being used to support and solve problems in standards. So that's really the first relationship trend between standards and AI, and it's probably the most obvious trend, right? Okay, so that was the first relationship trend between standards and AI. What's the second relationship trend? Well, here's a more complex example of a neural network, and I found this doing a quick Google search. And this neural network is actually used to predict earthquake data. And it was actually trained on a large set of earthquake data, related earthquake data. And as you can see, neural networks can become very complex, right? They can have a lot of neurons and a lot of different connections or weights between these neurons. And it's because of this complexity, right, in terms of computational needs, power needs, memory needs, that you start to see the need for this second relationship trend between standards and AI. And that is that standards are actually being designed and evolved in 3GPP terminology to support AI, right? So there's actually two relationship trends between standards and AI that we're seeing today. And the first one, again, is standards are being evolved or designed to support AI. And then AI itself is being used to support problems in standards. So really, if you step back, you kind of see, based on these two relationship trends, how pervasive AI is becoming, right, and will become as we move forward in the future. So now I'm going to focus on some specific examples of how AI is being used to support standards. All right, and I'm going to start with an example in the 5G context. So mobile devices like smartphones, automobiles, robots, they're starting to replace traditional algorithms with these AI ML models. And as we just talked about, AI ML models are very complex, right? So there's this trend of actually splitting or distributing AI ML models. So they would split this neural network between the mobile device and the network endpoint. So you might have part of the neural network performed on your mobile device and part of the neural network performed on a network endpoint, like the cloud or an edge server. So you might want to run like the latency sensitive or privacy sensitive parts of the neural network on the mobile device and the more power intensive parts on a network endpoint. So one example use case of this, you might think of, you're wearing virtual reality or augmented reality glasses. You get off a bus and you're right next to a base station. And in that case, you might have excellent wireless coverage, right? And so your augmented reality glasses might want to push more of the neural network that it uses for object detection off to the network. And so that's one example. And then imagine you walk farther down the road and you come to an area where the wireless coverage isn't as good. So in that instance, the augmented reality glasses may actually want to perform more of that neural network on the headset itself, right, to make sure latency requirements are met. So that's one example of how AI ML splitting could be used. The other example is shown on the bottom part of the figure, and that's the distributed AI ML model. And in this case, what you're seeing is the mobile device may actually want to download these neural networks on demand. So one example use case here would be for automatic speech recognition, right? Oftentimes your mobile device would take a sample of your speech, pass that speech off to the cloud to perform recognition, and then pass the results back to the mobile device. But we're seeing there's some use cases where you actually want to perform the entire automatic speech recognition on the phone itself. And in those instances, that algorithm is actually pared down, right, because of the complexity of these algorithms and the capabilities of the mobile device. So it might not be as robust, for example, to different noise environments that you may be currently located in. And so if you're in an environment where the noise isn't optimal for that automatic speech recognition neural network, you can actually request from the network to download on demand another automatic speech recognition algorithm that's more optimal for that noise environment. So that's one example of distributing AI ML models. So because of this, 3GPP has been working on service and performance requirements for this new AI ML traffic type in the current release of 5G. So this is one example, again, of how standards are being designed or evolved to support AI use cases. And now to provide one more example, and this is in the context of MPEG, which puts out video compression standards. So machine vision is becoming a very important use case. right, for intelligent transportation, smart cities, IoT. And in machine vision, you use a neural network to perform tasks like object detection, object recognition, object tracking, instance segmentation. Because machine vision is becoming so widespread, there really is a need to optimize the compression of the video that these neural networks are processing. And so what MPEG is currently working on is a video coding standard specifically for machine vision tasks, and that's referred to as video coding for machines, or VCM. And the goal of VCM is actually to provide a compression efficiency beyond that of the state-of-the-art video coding standard, which is VVC. And VVC was designed for and was optimized for the human visual system, right? But when we're talking about machine vision, we're talking about we're not talking about a human looking at this video, right? This is going to be processed by a machine, and that machine is going to provide a result. So it really wasn't optimized for this use case, and that's why MPEG is currently working on this new video compression for machine standard, or VCM. And the framework for VCM is actually shown on the right. So the way this would work is part of the neural network for performing machine vision would actually be performed before the encoding process. So the first few layers that are responsible for something called feature extraction would be performed, and features relate to lines or curves or more complex objects like someone's face, a body, or even whole objects. So the first few layers of this neural network would extract features, and then those features would be packed into a video frame. And that's what I'm showing here in the figure. And then the encoding process would happen. You'd have a video encoder specifically designed for this type of information, for this type of video. And then after the encoding's done, it would be passed to a decoder. It would be decoded, and then the features would be unpacked and then passed to the remaining layers of that neural network for performing machine vision. So this is one example of how the MPEG standards are working to support AI use cases. Okay, so now I'm going to turn to just a few examples as well on the other side. So how is AI being used to support standards? So in release 18, again, this is the current release that 3GPP is working on of the 5G standard, 3GPP is specifying data collection enhancements and signaling support for AI/ML-enabled RAN intelligence for different use cases like network energy savings, load balancing, and mobility optimization. And just to give a more concrete example of this one, so for network energy savings, yes?
They're just waiting for people.
Oh, okay. I thought someone was raising their hand. Sorry. No worries. Okay, so for network energy savings, so in this case, the way traditional cellular networks would work is to save power, you can actually turn off cells in the network. So based on the current traffic load being below a threshold, the network may actually choose to turn off that cell to save power. The problem with that is it's a very simplistic way of doing that, right? If you turn off a cell based just on that threshold being, the traffic load being below a threshold, it might not be optimal, right? You might actually end up using more power. So it's not considering all the variables it should. So that's one area where you can use an AI/ML model to consider all these variables that may have a nonlinear relationship to more optimally predict when to turn off a cell. And so what 5G is working on is they're working on this data collection enhancements and signaling support to support these use cases, and that's what's shown in this figure here. And then just to provide one more example, and I think this is the more interesting example of how AI is being used to support the 5G standard, and that is it's actually in the air interface. So in release 18, 3GPP is currently studying AI/ML for enhancing the 5G air interface for 3 different use cases: CSI feedback, beam management, and positioning. And really, a lot of people are saying this is the precursor to 6G, one of the foundational pieces of 6G, where maybe the entire air interface will be replaced by an AI/ML model. And the air interface is basically referring to the physical layer of the protocol stack that is responsible for reliably transmitting information over the medium, which in this case is the air. So this is going to be probably a foundational piece to 6G, sort of like what OFDM was to 4G or massive MIMO was to 5G. And so the 3GP is currently working on the collaboration levels necessary to support this use case. And then my last slide here is again going back to the MPEG standard. So in MPEG, the new VVC standard offers bit rates about half that of the prior video coding standard, which was HEVC. But it does that at a much higher complexity, right? So for each new generation of these standards, what we're seeing is you're getting some gain, right? 50% gain, but you're doing so at a much, much higher complexity. And the way these video coding standards work is they're typically adding more ways of partitioning the blocks that they're working on and adding additional coding tools that the encoder can choose from. So that way it can provide more compression efficiency based on the number of choices it has. But at some point, it becomes impractical, right? So MPEG is actually looking at using neural networks, and they're currently investigating neural network-based video coding to change this model. And they're looking at two specific approaches right now. They're looking in the first approach to employ neural networks in the hybrid video coding framework, which is shown here in this figure. And this is the standard coding framework that's been used for over 30 years now. Pretty much every generation of the video coding standard has used this framework. And in this approach, they're looking to replace one or two of these modules with neural networks. But in the second approach, they're actually looking to see if they can create an end-to-end based neural network video coding technology where the entire traditional hybrid video coding framework would be replaced by two or more neural networks. And that's the more drastic approach. So I don't think we're going to get there yet, not in the near term, but eventually I think that's where the standard's going. Video compression will be entirely performed by an end-to-end neural network approach. So with that, that's my last slide. Thank you all for listening. Appreciate it.
Thank you, Kevin. Are there any questions from the audience? If you do have questions, just to remind you, we have mics here, and since we have an online audience, I would love to have you guys come up and speak. I do have one question, Kevin, if you would answer. I'm really not a technical person, not a legal person. I'm an economist, so it may be stupid. But with the whole AI and neural network thing, my understanding is that these models evolve with training data, right? Especially when they're unsupervised. How would that work in a standard where you kind of set a standard to a certain specific parameter? Will that evolve too in different versions, or?
Yeah, absolutely. I think the AI ML usage in standards could be trained, supervised or unsupervised, on a large set of training data, offline or online. And I think the standards that are like 5G that's investigating the use of AI ML for certain use cases, they're really looking at the signaling aspects, right? What needs to be supported in terms of the data needed to train these models. So that's really what they're focused on. The AI ML model itself is probably going to be proprietary in a lot of these use cases. But the signaling needed to support the training, for example, would have to be supported by the standard. They would have to introduce new features for that purpose.
Interesting. So there will be some proprietary AI and some standardized publicly.
Yeah, but when they're talking about an AI native air interface, which was the last example, that's really going to be, an AI model in the standard, not a proprietary feature, because it's going to be changing the signaling altogether. So.
I understand. Do we need a mic? Yeah, because the online audience, they would need to hear.
So Keyvan, one question I had is, right now all of these examples are from high technology, primarily communications. Are there other verticals where standards, there are many verticals where standards are important, some of the more meat and potatoes industries as well.
Yeah.
Oil and gas exploration, drilling,
Yeah.
so forth. So, I mean, that's just one example. But are there other industries where these kinds of, amalgamation of AI with those standards is happening that you're aware of? I mean, the examples you gave are, of course, high technology. But I'm just wondering if you see anything down the line where other industries will have similar interactions with AI.
Yeah, so at Ofinno, we're focused on cellular standards, video compression standards, and Wi-Fi standards. And we're seeing this at the very beginning part of the trend right now in those standards. So I think it's just a matter of time before, AI gets pushed into these other standards. But I think it's going to start with these larger standards, more complex standards first, and then eventually it's going to work its way down. I think it's just inevitable, and it's just going to take some time.
Yeah, one of the things I'm thinking of is, I mean, the communication technologies are all pervasive, but through IoT, for example, they're going to make their way into the more traditional industries because they're going to start using IoT for all kinds of sensing and telemetry, and maybe there, some interface with AI could come in.
Yeah, you see AI can be used for so many different use cases, right? Whenever there's this complexity issue and you have so many inputs that you need to consider.
Multivariate problems, basically.
Yeah, it's just a matter of time, I think.
All right, thanks.
Yeah. Great, thank you. Are there other questions?
Kavon, thank you for the presentation. A question I have is about future. Since you're talking about AI training the standards and standards working for AI, are we also looking at standardizing AI as well? And that's an interesting point because we have, various systems, various companies, and at which point do we need to come to a certain conclusion because AI that I'm using may be producing slightly different results than AI you're using?
Yeah, it's a great question, and I think there is some efforts right now that are underway they're working on standardizing AI. I honestly don't know though. I haven't given it much thought, but I can definitely see a need for that. But AI is such a black box, so I'm not really sure how you're gonna standardize that black box.
Right. Yeah, because obviously there will be a need for cooperation between within industries and companies on agreeing on certain standardization, right? And so AI will play a big role in that. So that's probably a big next big question for all of us.
I think so. I think you're absolutely right on that.
Thank you.
Yeah, thank you.
Thank you.
I thought your explanation was great. The test score is very simple. Quick question on that point. Are we concerned about, when we talk about standardizing AI, it seems pretty foundationally mathematical, right? So are we concerned about this US 101 type of rejections for this stuff, right? It seems to me we're getting closer to pure math like Fourier transforms when we talk about these neural network models, right? So is that a concern? Are you seeing that?
Yeah, from a patenting perspective, I think most people are, again, it's a black box, right? The internals are black boxes. So I think most people are focusing on protecting use cases, right? Where are you using that AI model and what's that use case? So they're protecting it at a more high level. And then, training data is another form that you can protect using copyright, for example. So those are the types of protection they're looking at. So one-on-one issues, I don't think they're going to come into play because I just don't think you're ever going to get to that point where you're trying to protect the internals of the neural network using patents, for example. Yeah.
Great. Any more questions? If not, please another applause for Kevin. This was really exciting. Thank you so much.